there in your packet? So homework 22 is the last of chapter 3, which was really short, has to do with graphing inequalities. So when you graph an inequality, the first thing you do is just graph it like you would if it had an equal sign. If I were going to graph the line y equals -5, we said that if it's y equals the number, we know our line has to go horizontally. And that if we made a table and put numbers in, we know all the y values have to be -5 in our table. So it tells us y has to be -5. We then said we could pick whatever numbers we wanted to for our x values so that we could get our line. I might use 0, I might use 2, I might use -2, whatever I happen to pick. So putting my dots on my graph, if y equals -5, on my y-axis, right there's where -5 is. It happens to be the point 0, -5. If I plot 2, -5, I go over 2 and down 5. If I plot -2, -5, I go back 2 and down 5. And you can see what happened. The dots ended up being in a horizontal line. If you knew that already, you could just click on y equals -5 and make your ruler go straight so you can draw your line. So that's the line y equals -5. Once you have the line on there, you want to check. If you have a less than or a greater than, you're going to change it to the dashed line. If it has the equal to underneath, then you leave it the solid line. So on this one we look up here, it just has the less than, it doesn't have the equal to, so we have to click on the tool that changes it. Then we click on our line, and instead of having a solid line, it's going to be a dotted line. Probably erased too much of my line. But it's going to be a dotted line in this case. Once I've checked my line and I know if it's solid or dotted, then I'm going to check my shading. Since this says y is less than -5, I'm looking on my y-axis for the values lower than -5, means I would shade underneath my line. You're going to have a little tool that sort of looks like this with a whole bunch of little dots. Click anywhere under the line, it's going to add all those little dots underneath there and shade that little section in. So that's what my graph would look like. Got a line at y equals -5. It's a dashed line because it's not equal to the line, and I shaded less than the line, so I shaded down.
I thought you just said if it's... Okay, never mind, I read it wrong.
So on number 2 here, we have x is greater than or equal to -2. We're going to start by graphing the line x equals -2. If x is equal to -2, if I made a table, all of my x values have to always be -2. My y values can be anything, 0, 2, and -2, or whatever ones you want to use. And hopefully I know that the line, when I'm done, should end up going vertical because it's an x equals a number instead of a y equals a number. Otherwise, if I just plot my points, -2, 0 would be back 2 but up 0. It's right on the x-axis at -2. X equals -2. -2, +2 would be above that. -2, -2 would be below that. My dot should line up straight up and down and touch the x-axis at -2. So in this one, when I look at my inequality symbol, this one does have the equal to bar underneath my inequality. So this line is going to stay solid instead of being a dotted line. Then I have to do my shading. I'm looking at my x values. I want my x values to be greater than -2. So should I shade on the right or the left of that line? To the right, right? My bigger numbers go to the right, and so I would click on it, and it's actually going to shade in the whole section for you at once. I just got to scribble and make it shaded. But it's going to look something like that. A solid line, you shaded to the right since you shaded greater. So number 3 says graph the inequality for x is less than 1. If I'm going to graph x is less than 1, I'm going to start by graphing x equals 1. Am I going to have a vertical or a horizontal line?
Vertical.
It's going to go vertical. And again, you really don't have to make the table unless you want to. I know x is equal to 1, so on my x-axis I know it's going to be 1. And then I know my line's going to go vertical, so I just need to have a point above that and below that somewhere so that I can draw, if I could draw straight, a line going through x equals 1. Now on this one, if you look at the inequality, should that line stay solid or should I change it to the dashed line?
Dash.
This one's got to be dashed. It doesn't have the equal to underneath. And so we use that little tool that sort of looks like this. Click on our line and make it a dotted line instead of a solid line. And then when I shade, this time I'm shading x is less than 1, so I would shade to the left. Click on my shading tool and click anywhere on the left side, and it's going to shade that whole side in for you. Once you do the ones where you have the horizontal and vertical lines, then you'll do the ones that are in slope-intercept form. So again, we pretend it says y equals negative 2x plus 5 to start with, and then we're going to graph that line. We said when we had it in slope-intercept form, we just use nice, easy numbers for x. I usually just pick like 0, 1, and 2. Unless I have fractions, then I have to use 0 in multiples of the denominator, but since this one doesn't have any fractions, and I plug them in. If I put 0 in for x, negative 2 times 0 is 0. 0 plus 5, still 5. We know that n number should be our y-intercept. If I put a 1 in, negative 2 times 1 is negative 2. A negative 2 plus a 5 is 3. If I put a 2 in, negative 2 times 2 is negative 4. Negative 4 plus 5 is 1. Technically, you only have to have 2 points. We do 3 just in case we mess up on one. You could do 4 or 5 if you really wanted to. So 0, 5, 0 over, up 5. 1, 3, 1 to the right and up 3. 2, 1, 2 to the right and up 1. Again, we have to draw our line solid to begin with, which I did. And then I use those same rules as I had before. I look at my inequality symbol. Should that stay solid or should I change it to a dashed line?
Solid.
It's going to be solid because it does have the equal to, so I leave it solid. Now the shading part is where people kind of get confused because we're looking at the y.
It's going to be to the left.
So you think of left or right, but you're really thinking up or down.
Yeah, the bottom.
Because the y-axis goes up and down. I'm shading less than, so look at your y-intercept and go straight down. That's where you want to shade, this section of your graph. Y is less than, so I would go down from my y-intercept. And so, although it looks like it's shaded on the left, it's really shaded below the line. So, again, I'm pretending that that says y equals negative 3x minus 3, and I'm putting some numbers in so that I can plot some points. If x is 0, what do I get for y? Negative 3. If x is 1, I get negative 6. And if x is 2, negative 9. So negative 3 times my x value minus 3. If you need to, use your calculator. Plotting those points. 0, negative 3. Over 0, down 3. We know that number should be our y-intercept, so we touched our y-axis at negative 3. Then I go 1 over, down 6. And 2 over, down 9, way down at the bottom of my graph. Draw my line in there. But then I've got to go check. Should that be a solid line or should it be a dashed line?
Dashed.
going to be a dash line because we don't have the equal to. So then we have to use our little tool that changes our line to a dotted line. I'll use my eraser. Make it look like a dotted line. And then we have to figure out our shading.
The bottom portion.
The bottom portion. Again, we have a less than, and so if I went straight down from my Y intersection, I'm underneath my line, which looks like it's on the left, but is underneath that line. So number 6, this time when we do it, we're pretending it's y equals 1/3 x plus 1, and we have to be a little more creative at picking our points. 0 is always a good point to pick, but then we want to use multiples of our denominator. Multiples of 3 would be numbers like 3 and 6. So those would be good ones to pick. So if I take 1/3 times 0 plus 1, well, anything times 0 gets rid of that. You just get the end number, the 1. So that one's easy to do. If I do 1/3 times 3 plus 1, the 3's cancel out, so I get 1 plus 1, 2. If you're really bad with fractions, you can always use your calculator. 1/3 times 6 plus 1. Well, 3 goes into 6 2 times, so I have 1 times 2, which is 2. 2 plus the 1 on the end is 3. So 0 over up 1, just double checking, 1 is our y-intercept. Yes, it is. 3 over up 2, and 6 over up 3. And I draw my line. Should my line be solid or dashed? Solid. It does have the equal to underneath, so this one we leave solid. And then we want to shade. If I'm going to shade greater than my line, would be on the top, right? I'm going up on my y-intercept because I'm going greater. So above that line is where it gets shaded. Something like that. Then it gives you the ones that were in standard form. When we graphed the ones in standard form, we found our x and our y intercepts. So if we were making our table, we put 0 in for y and 0 in for x and found those 2 points. Again, we're pretending it says 4x plus 3y equals -12. And we do our x and y intercepts because they're kind of easy to do. If I put 0 in for y, it gets rid of the y term, so I'm just taking -12 divided by my coefficient of x, -12 divided by 4, -3. That's pretty easy to do. If I put 0 in for x, I get rid of my x term. -12 divided by the coefficient of y of 3 gives me -4. So my x-intercept is at -3. My y-intercept is at -4. I have my 2 dots. I can now draw my line. Again, I double check. Should that line be solid or should it change to a dash line? It's going to have to be a dash line. Now, this is the weird part, because you can't always follow that inequality symbol, because if I would solve that equation for y, sometimes my symbol switches around. So what we do is we test the point 0, 0. 0, 0 is right in the middle and it's easy to test. What I'm going to do is I'm going to put 0 in for x and 0 in for y, and then see if I have a true statement or not. Well, if both of these two things are 0, it makes that whole side 0, right? Is 0 less than a -12? Is 0 less than a negative number? It's not, right? 0 is bigger than a negative number. So that means I'm not going to shade the 0, 0 side. I'm not going to shade this side. That means I have to shade this side. So I end up shading below my line over here. So number 8 here, if I am going to find my x and my y intercept, putting 0 in for y and 0 in for x, I have negative x plus 3y. We're pretending it says equals 6. If I put 0 in for y, what would I get for x? Negative 6, exactly. Because I'm going to take 6 divided by negative 1, negative 6. And if I put 0 in for x, I'm going to get 2 for y. Because we're taking 6 divided by 3, which is 2. So my x-intercept is negative 6. My y-intercept is positive 2. Again, on these, sometimes you do get fractions and you have to use the plot point tool and have the computer plot it. Then I draw my line. And I double check. Should my line stay solid or should I change it to a dashed line? It's going to be dashed. So I've got to make it a dashed line instead. Now I'm going to check my shading. I'm going to test 0, 0. So negative 0 plus 3 times 0, is that less than 6? Again, this whole side's just going to end up being 0 because I put 0 in for x and for y. Is 0 less than 6?
Yes.
Yes, it is. So that means we do shade the side where the 0, 0 is. This time we're going to shade over here below our line because the 0, 0 is below our line. And so it looks something sort of like this. Number 9, we have 2x plus 3y. We're pretending it says equals negative 9. We're going to find our x and our y intercept. So if we put 0 in for y, what is x going to be? Negative, right?
Yeah.
Negative 4.5 or negative 9/2 if you put the fraction in. The computer will take it either way. If I put 0 in for x, I'm going to get negative 3, right? Negative 3. So on the first one, you'll have to use the plot point tool and let the computer put the negative 4.5, 0 on there. We're going to just estimate where it is because we know about where negative 4.5 would be. And then the 0, negative 3 would be my y-intercept so that I can draw my line. And should that line stay solid or should it change to dashed?
Solid.
It's going to be solid, which we have, and then again we're going to test. If we test 0, 0, 2 times 0 plus 3 times 0, is that greater than or equal to negative 9? Is 0 greater than or equal to a negative 9?
No. Yeah.
Yes, it is. 0 is greater than a negative number, right? The equal to, it's probably never going to be, otherwise you'd be right through 0, 0. But yes, 0 is greater than negative 9. So yes, that's a true statement. So we are going to shade the side with 0, 0, which is this side up here. And so my graph looks something sort of like that. The next ones, we are just going to translate these into inequalities. We're not going to do any solving. It says, Scott drives a truck for a soft drink company. His truck is filled with 15-ounce cans and 70-ounce bottles. Let C be the number of 15-ounce cans the truck is carrying. Let B be the number of 70-ounce bottles. The truck must be carrying less than 4,000 pounds or 64,000 ounces. Using the values and variables given, write an inequality that describes what's going on. So I have 15-ounce cans, so if I take 15 times the number of cans, I'm going to have the number of ounces that I have cans. I'm also carrying bottles. Each of my bottles is 70 ounces, so if I take 70 times the number of bottles, I have the number of ounces of bottles that I'm carrying. The truck must be carrying less than. And which one of those two numbers there should I be using?
4,000.
Go back and look at the question. What units are you using on the first part of the question? Ounces. So if I'm using ounces up there, I have to use ounces in my problem, right? So instead of using the 4,000, I'm going to use the 64,000. So they're not going to have you solve it, they're just going to have you translate it, and that's what we're going to have. Number 11, in a race, car 1 went an average of 150 miles an hour for X hours before dropping out. Car number 2 went an average of 170 miles an hour for Y hours before dropping out. The distance car 1 traveled was at least that of car 2. Using the values and variables given, write an inequality describing the situation. So for the distance for car 1, how would I write that down? What's it tell me about car 1?
15 over your x, or 150.
150. Now if I'm going 150 miles an hour for X hours, how do I find the distance? You multiply them. So 150 times X would just be 150X. That's going to be the distance the first car went. Rate times time equals distance. The second car went an average of 170 miles per hour for Y hours. How am I going to show his distance? Multiply again. 170Y. Now, we have to figure out, because we've done this before, what symbol do I use for at least? Car 1 went at least that of car 2.
Greater than or equal to.
Greater than or equal to, exactly. There's my expression then. Right, you had that little table to add at most, at least, not, not less than, whatever all those weird sayings were. And the last one. A landscaper is planting a tree that is now 48 centimeters tall. The tree will grow 4 centimeters per month for X months. The tree will grow to be less than Y centimeters tall. Write an inequality showing this relationship. So, my tree started out at
48.
48 centimeters. It is now going to grow. So if it's going to grow, what am I going to do? Add to the tree. It's going to grow 4 centimeters per month for X months.
4x.
4X, exactly. The tree will be less than Y centimeters tall. So my inequality, 48 plus 4X, is less than Y. Those ones will probably take you a little bit of practice. Just write down lots of examples. So if you get to it on the assessment, you've got some things to look at. That is the end of chapter 3. So if you look at your pie chart,